Today we are going to talk about how Paralus implements zero trust principles. We'll touch base upon a few key principles about zero trust, and we'll see how Paralus actually implements this. So I am Nirav, by the way, software developer by profession, amateur investor by passion. So I work on building tools that helps infrastructure management at InfraCloud Technologies. I'm a maintainer of Paralus, a CNCF sandbox project which helps with Kubernetes access management, open for chai and gupshup about cloud native product development and financial management. So we can connect and here are my handles. All right, so this is going to be the agenda. What is zero trust security? We'll touch base about what is zero trust principles. We'll talk about what is zero trust in Kubernetes, and finally we'll look at how Paralus implements it and maybe a short demo. So let's begin, right? How many of y'all have kind of been in a relationship where, like, they are like, okay, where are you going? When will you be coming back? Right? So these kind of questions which validates and verifies, right, every action of you. It kind of, if you have gone through this, you probably have already gone through a few principles from zero trust. All right, so we'll look at them. So traditionally, right, this is how all the infrastructure was managed, probably a decade or a couple of decades ago. I'm not that old, but yeah, that's how it was managed. And all of the your databases, your servers, and all your devices, and even the users were probably contained to a data center. And every organization had a data center, by the way, back then. So this is how it used to be. And there used to be a firewall around these applications and systems that you maintain, right? And firewalls are still relevant. Although in case if you are running your applications across on-prem and across different cloud providers, you need to have firewalls configured across all of them, right? So this is a firewall, right? There used to be firewalls, and let's say a hacker, and Ram, my dear friend, actually spoke about a lot about security, right? So let's say a hacker comes, and we even saw about a couple of instances what happened. So a hacker comes along, and somehow he gets access to the key to your firewall and is able to get into your firewall, which essentially means he can access all of your systems, all of your databases, which are kind of interconnected with each other, right? So effectively, he has access to your entire organization's environment and all the applications to it. So which is bad, right? So this is where we were, and after a lot of iterations and after a lot of things, the recent thing that is happening in the market is basically zero trust, right? Since 2010, it was kind of termed by John. So this is what we want to achieve, and this is what zero trust kind of comes to, where we want to kind of have little network meshes which are secure on its own, right? So we have these databases which are secure separately, all your devices which are secure separately, your cloud infrastructure is secured separately, and all the users are also secured separately. So in this way, what happens is, in case if an intrusion ever happens, which we don't expect to, but if it ever happens, it's contained to only that particular piece of infrastructure, and it doesn't spread across. This is what we want to achieve, and yeah, this is the guy actually who's kind of doing everything. So he ensures that your infrastructures are kind of managed. He ensures that you have access to that infrastructure and only allows you in. He ensures to check your identities every time you use something. He ensures to get your user and password and then allow you access. He even ensures that all the devices that you're bringing in are being connected to the infrastructure are also kind of authenticated, and all the applications as well that you're using, including networks and also the data. So he ensures that you have access to the data. Only then you can see the data. So this is the guy who's gonna help us implement zero trust security in Paralus. All right. So we look at a few principles. There are a bunch of principles, but we'll just touch base upon a few that are critical. And one is you verify every user and service, right? So every time a user logs in, you need to provide your ID and credentials, and that is being verified. And that's not only applicable to users, but also for applications and services that are connected to it, right? The second one, the critical one, is you provide least privilege access, right? If someone just comes to your door and asks for something, you just give them something. You don't invite them over and show them around your entire house, right? Unless you know them, of course. So that's what is provide least privilege access. And the third one is essentially just-in-time access provisioning, all right? So you give access to the person who is asking for it, provided they are authorized to get that, you give them the access right about then, let them do their job and revoke the access back again, right? You don't want to give a key to someone, and just forget about it, right? To your house or something. You just give it to them, get the work done, and get the key back, right? So just-in-time provisioning, that's the third main principle that Zero Trust provides. And the fourth one is definitely, whenever we talk about a lot of security and everything, auditing and logging comes along as part of the governance and whatnot, right? So we need all of this information in order to keep a track of who's accessing your systems and everything. So we'll look in detail about all these four principles and how Paralus kind of implements them in further slides. But before that, we'll touch base on what is Zero Trust in Kubernetes, right? So what do we want? In Kubernetes, you want to ensure that your access to all the clusters are kind of secure, right? First thing. The second thing, you want to ensure that you have a controlled access given to the user who's requesting, right? If I have an access to one cluster or probably X clusters, I should be able to access only those clusters and not beyond that. If I have access only to certain resources and certain namespaces, I should be able to access only that and not beyond that. So control user access. And the final one is, you continuously audit all the transactions that are happening in the system and capture all that. So these are the three main things. Although few of the things that we spoke about, Kubernetes already natively handles it through the ways of RBAC and even auditing. But imagine that you have to do for tens and hundreds of clusters that are out there, right? Doing it for one cluster is fine, but at scale is where the challenge actually arises and it's difficult to manage. So that's where Paralus comes into the picture. So we'll quickly look at what is Paralus. I'll introduce you to Paralus and we'll go to the demo straight on. Alright, so Paralus is a free and open source tool that enables controlled and audited access to Kubernetes infrastructure. It comes with a GUI, it ships within CLI and an API as well. So you can just have a look. It is a CNCF sandbox project, and we'll see how Paralus achieves Zero Trust. So we spoke about a few points, right? Four principles to be particular. The first one was verify and validate. So for that, Paralus actually uses Kratos, which is one of the user and identity management tool already available by Ori for its authentication mechanisms. The second one, to validate, it uses Casbin, and these two, combination of Ori Kratos and Casbin together, kind of helps all Paralus core achieve or implement the validate and verification process from the principles. The third one is, Zero Trust as a principle. It says that you don't trust anybody, right? Not the user, not the service, not the application, not the networks. You don't trust anybody. Ensure that you validate each and every request that comes to you, be it from someone you already know already. So the third point is it implements MTLS across components. So there are various components or a few components essentially that Paralus runs, and in spite of being Paralus owned components, we actually ensure that they are kind of authenticated. And how we do that is by, Paralus core effectively acts as a certificate authority, and all these other components that go around it and interacts with Paralus core has to present the identity, a certificate saying that, hey, you know me, you've given me the certificate and I am interacting with you, I am giving you this request, respond back to me, right? So it does implement that as well as an additional security mechanism. The fourth is just-in-time access to Kubernetes clusters. That was one of the third principles we saw in Zero Trust principles. So Paralus ensures that whenever you ask or send a request, it ensures that it creates the service accounts and effectively all of that in the target cluster just when you ask it, and it doesn't create it when the user is created to all the clusters. So that's not how it works. And the fifth one is monitoring and auditing. So that's also baked in. So all these Zero Trust principles that we spoke about are baked into Paralus. And all you need to do is kind of install it and get it up and running and probably configure your target cluster. So we look at that now. So before going into the demo, a short slide. So here on the left you see users, kind of, be it people or Jenkins, any other system, CI/CD system that kind of interacts through your kubectl or maybe your API client or maybe your even kubectl, right? They interact directly with your Paralus core, which is installed somewhere, And Paralus core ensures to validate the user or the service, the request that's coming from it. It ensures that it verifies and validates both of them. The third one, it even kind of audits all the activities that you do on the system, right? And on the right side, you see uh, core effectively talks to an agent, right? So there is an agent which effectively we'll have to install in all the target clusters that Paralus will interact with. And that agent, and you still see a firewall, right? So the firewall is still relevant. It's not gone. It's an additional security mechanism that's already in place. And now the agent is responsible to actually dial out all the connections, and it talks to the Paralus cluster or the Paralus core, which is effectively has all the ZTKA principles baked in. So it talks to the Paralus core and ensures that all the interactions go only these through this through a long-lived Unix socket connection, right? So this is what it is. We'll come back to this slide if required, but we'll go through the demo quickly, and we'll kind of relate to how this entire interaction is happening. So yeah, while I get the demo, these are the website URLs. It's paralus.io in case if you want to quickly have a look at what it is and learn more about it. You can take a note of that. All right. All right. So while this is happening, so I already have a predefined server, and there are a few configurations that I've already done. So this command over here, which is helm install your release name and Paralus/ZTKA and a bunch of values that I'm passing in, kind of installs the Paralus application to you. So right now it's installing it for me on an Oracle VM machine that I have, and I've already associated a domain name with it. So let's check whether all of them are running. We'll give it a minute. Hopefully it shouldn't take more than that. All right, I think it's all right. All the pods are running, so let's get into it, right? So by default, Paralus gets installed with the username that you provide. So which is admin@paralus.local. I have just left it to be that. And I have already installed that Paralus, and I am able to access using this URL over here, which I had pre-configured. So I'm just going to log in and put in the default password, which will actually ask me to mandate me to change it. So let me do that. All right, so this is how it looks like. It's categorized into different projects. So I'll quickly get into creating a cluster. So what I'm doing is I'm importing a cluster. What we are going to do next is essentially I have a local kind cluster running in my machine. This Paralus application is running in some Oracle Cloud VM, right? And I'm going to connect and I'm going to run commands from that Oracle Cloud VM and execute kubectl commands right in my kind. So that's what we're going to try and do. So while this is getting created, let me create a client cluster, and let me come back here. So this YAML that we download is effectively for the target cluster. We need to install that into our target clusters, respective target clusters, and it can be anything, right? Right from my local kind to any of the cloud provider provided Kubernetes environments. I'm running out of time, but yeah, we'll just do a quick wrap up of this. All right. All right. So this should be done in not more than a few seconds. Again. And we'll be able to see that the Paralus actually connects to the target cluster, which is the local kind. So what happens over here, right? The agent kind of in the background, it asks or it generates a CSR and it requests Paralus core that, hey, sign me this certificate. I am something that, with the token that you provided. So I am a service, an application that you've already verified once and you've generated a token, you've given a key to me. Please sign the certificate, which I'm going to use for all my further interactions with you, right? So that's what happens in the background. So now okay, this is not good. What happened? Let me give this one last try. Let's see if that comes up. Okay, I think there's some issue downloading the image, but I do have a backup video. I'll play that if this doesn't come up in a few seconds. All right, I'll go ahead with this, right? Yeah, so effectively I'm playing the same thing that we are seeing right now. So what would have happened is, you would have seen, we built the cluster. So yeah, you would have effectively seen that the agent is installed, and once the agent is installed, you will be able to kind of do a kubectl right from here. And this particular user that I've used in the demo is a namespace read-only user, right? So he has access only to a particular namespace within that local kind cluster that I created. So I've logged in using that, and I'm just doing a kubectl get ns, and you guys can see that it's forbidden because a namespace only user has only role and role bindings and not cluster wide access. And this guy has access only to the Paralus system namespace. So we see that the same response we get on the Paralus web shell as well. So we are able to do get only that Paralus namespace. And here you see, just in time, we created a service account, which was like almost 24 seconds ago, right? And the corresponding service account for the user as well as the role and role binding got created by the Paralus system itself. So which effectively brings in the principle of just-in-time access, right? So yeah, this is, and I'm trying to create, this guy is a namespace read-only, so it should just give me an error saying that, hey, it's not allowed. Yeah, so it's going to fail. I'll move on a little bit. We'll talk a little bit about auditing. So all these users, right, that are effectively running commands from the web shell or even by downloading the kubeconfig, you'll see that all these commands that are run against the target clusters are captured, and you'll be able to see all of them in the UI over here, which are run by which users and against which cluster. Even the ones that got failed are getting captured. So in this way, all the auditing that happens in each cluster are kind of bundled in. Let's imagine you have 10 and tens or hundreds of clusters. This is going to give you a simple view about who accessed which cluster and using this simple dashboard over here. So that's where Paralus comes, becomes a little handy. Yeah, so this is the end of the demo. Okay, this is running now, but anyway, effectively that's what it would do, right? So yeah, effectively that's what it would do. So this is an admin user, and that's why we are able to see all the namespaces. So this is already there. This is public actually. In case if you guys are interested to kind of try this, login and maybe bootstrap your local kind cluster, feel free to do that. Maybe reach out to me. I'll give you a user using which you can do it. And if you're able to successfully bootstrap it, we have a few things for you guys as well. So, and I'll end the demo with this. That's it, guys. Thank you. That would be my presentation. If you want to connect now or later, maybe you can scan the images. It is time bound. Good question though. I didn't touch base about that. So it is time bound. It is going to stay there for like 8 hours. Though it is configurable using Paralus, you can configure it to as less as 10 minutes or maybe as high as 30 days. So it is time bound.
Thank you, Nirav.
Thank you.